Data visualization is one of the most important parts of data analysis. Powerful visuals show stakeholders what your data means in a clear and compelling way, and highlighting key insights. Visuals help bring the story of your data to life, and make that story easier to understand. You might remember the sneak peek I gave you of R's data visualization powers. I created those visuals with ggplot2, one of the core packages of the tidyverse. ggplot2 is R's most popular visualization package, and for good reason. It's a powerful and user-friendly data viz tool. Up next, you'll learn how to write and execute all the code we previewed earlier. You'll learn how to use ggplot2 to create a variety of plots, organize and represent different variables in your dataset, and customize the look and feel of your visuals. Working with ggplot2 can help you get the most out of your data. Your new data viz skills will also make it easier to learn other parts of R. Going forward, you'll be better able to visualize the results of any change you make to your data. Plus, you get an immediate result for all your hard work, which is one of my favorite parts of creating plots in ggplot2. Just enter some code, run it, and out comes a cool-looking visual that helps you and others understand your data. Visualization is a key part of a data analyst's workflow, and R lets you move back and forth between analysis and visualization quickly and easily. I'm looking forward to showing you what ggplot2 can do. In this video, we'll focus on ggplot2. We'll learn about its main features and functions, and how it can help you visualize your data. First, let's talk about some different visualization packages you can use with R. Base R has its own package, and there are other useful packages you can add. They'll help you do almost anything you want with your data, from making simple pie charts to creating more complex visuals like interactive graphs and maps. General-purpose packages like Plotly let you do a wide range of visualization functions. Others, like RGL, focus on specific solutions like 3D visuals. Some of the most popular include ggplot2, Plotly, Lattice, RGL, Digraphs, Leaflet, HighCharter, Patchwork, ggAnimate, and ggridges. Personally, ggplot2 is my favorite for data analysis. It's both powerful and flexible. With a little bit of code, you can create all kinds of different plots. You can use ggplot2 on its own, or extend its powers with other packages. Plus, it's the most popular visualization package in R. A lot of data analysts prefer to use ggplot2, which is why we're using ggplot2 here. ggplot2 was originally created by the statistician and developer Hadley Wickham in 2005. Wickham's inspiration for creating ggplot2 came from the 1999 book The Grammar of Graphics, a scholarly study of data visualization by computer scientist Leland Wilkinson. The first two letters of ggplot2 actually stand for Grammar of Graphics. And in the same way the grammar of a human language gives us rules to build any kind of sentence, the grammar of graphics gives us rules to build any kind of visual. So ggplot2 has some basic building blocks that you can use to create plots. In other words, when you learn the basic steps for creating a plot in ggplot2, you can reuse these steps to create lots of different kinds of plots. Plus, you can add or remove layers of detail to your plot without changing its basic structure or the underlying data. This makes ggplot2 really powerful. In the next video, we'll go over these steps one by one. ggplot2 has lots of other benefits too. You can create all different types of plots, including scatter plots, bar charts, line diagrams, and tons more. You can change the colors, layout, and dimensions of your plots, and add text elements like titles, captions, and labels. With just a little bit of code, you can create high-quality visuals. Plus, ggplot2 lets you combine data manipulation and visualization using the pipe operator. ggplot2 also has tons of functions that cover all your data viz needs. To give you an idea, check out the ggplot2 cheat sheet, which is a popular reference guide. You can find out more about the cheat sheet in an upcoming reading. It's not important to learn all these functions right away, or even know what they are. Over time, as you get into more advanced data analysis, you can learn about new functions as you need them. Just know that if you need to find a function for something, ggplot2 probably has it. And like we discussed, even the basic functions of ggplot2 let you do so much. We'll focus on some core concepts in ggplot2: aesthetics, geomes, facets, labels, and annotations. These might be new concepts to you, and that's okay. We'll learn about them together, and soon we'll explore each in detail. For now, let's get a quick preview. In ggplot2, an aesthetic is a visual property of an object in your plot. For example, in a scatter plot, aesthetics include things like the size, shape, or color of your data points. Think of an aesthetic as a connection or mapping between a visual feature in your plot and a variable in your data. We'll talk more about mapping later on. A geome refers to the geometric object used to represent your data. For example, you can use points to create a scatter plot, bars to create a bar chart, or lines to create a line diagram. You can choose a geome to fit the type of data you have. Points show the relationship between two quantitative variables. Bars show one quantitative variable varies across different categories. Up next, we'll talk about the facet function. Facets let you display smaller groups or subsets of your data. With facets, you can create separate plots for all the variables in your dataset. Finally, the label and annotate functions let you customize your plot. You can add text like titles, subtitles, and captions to communicate the purpose of your plot or highlight important data. That's all for now. Coming up, we'll use code to create our own first plot in ggplot2. You might remember that the penguins dataset contains size measurements for 3 penguin species that live in the Palmer Archipelago in Antarctica. The dataset includes variables such as body mass, flipper length, and bill length. Now, we'll learn how to use code to create those visuals. We'll go through the process of creating a plot step by step. We'll also go over some general tips on how to write code in ggplot2 and check out some useful help resources. First, let's log into RStudio Cloud. As we go along, I encourage you to join in and try out all the code in RStudio. Feel free to pause the video anytime you need to. We're assuming you already have the tidyverse packages installed. If you don't, refer to an earlier video or run install.packages tidyverse. Let's start by loading the ggplot2 package and the penguins dataset. Let's check out the plot that shows the relationship between body mass and flipper length in the 3 penguin species. The plot shows a positive relationship between the 2 variables. In other words, the larger the penguin, the longer the flipper. Now, let's check out the code. The code uses functions from ggplot2 to plot the relationship between body mass and flipper length. As a quick refresher, in R, a function's a name followed by a set of parentheses. Lots of functions require special information to do their jobs. You write this information, called the function's argument, inside the parentheses. The three functions in the code are the ggplot function, the geomePoint function, and the AES function. Every ggplot2 plot starts with the ggplot function. The argument of the ggplot function tells R what data to use for your plot. So, the first thing to do is choose a data frame to work with. You can set up the code like this. Inside the parentheses of the function, write the word data, then an equal sign, then penguins. This code initializes or starts the plot. If we stop right now and run the code, the result will be an empty plot. Let's try it. This is just the first step in creating a plot. The next thing you might notice about this code is the plus sign at the end of the first line. You use the plus sign to add layers to your plot. In ggplot2, plots are built through combinations of layers. First, we start with our data. Then, we add a layer to our plot by choosing a geome to represent our data. The function geom_point tells R to use points to represent our data. Keep in mind that the plus sign must be placed at the end of each line to add a layer. Adding a geome function is the second step in creating a plot. As a reminder, a geome is a geometric object used to represent your data. Geomes include points, bars, lines, and more. In our code, the function geom_point tells R to use points and create a scatter plot. We'll learn more about geomes later on. Next, we need to choose specific variables from our dataset and tell R how we want these variables to look in our plot. In ggplot2, the way a variable looks is called its aesthetic. As a quick reminder, an aesthetic is a visual property of an object in your plot, like its position, color, shape, or size. The mapping equals AES part of the code tells R what aesthetics to use for the plot. You use the AES function to define the mapping between your data and your plot. Mapping means matching up a specific variable in your dataset with a specific aesthetic. For example, you can map a variable to the x-axis of your plot, or you can map a variable to the y-axis of your plot. In a scatter plot, you can also map a variable to the color, size, and shape of your data points. We'll learn more about aesthetics soon. Mapping aesthetics to variables is the third step in creating a plot. In our code, we map the variable flipper length to the x-axis and the variable body mass to the y-axis. Inside the parentheses of the AES function, we write the name of the aesthetic, then the equal sign, then the name of the variable. We write the code, and R takes care of the rest. Using the penguins data, R creates a scatter plot, puts the variable body mass on the y-axis, and the variable flipper length on the x-axis. Our code follows the common sequence for creating plots in ggplot2. Earlier, we talked about the grammar of graphics, a set of steps for making all kinds of different plots. You can also think of this sequence as the basic grammar for making plots in ggplot2. To create a plot, follow these three steps. Start with the ggplot function and choose a dataset to work with. Add a geom_function to display your data. Map the variables you want to plot in the arguments of the AES function. We can also turn our code into a reusable template for creating plots in ggplot2. To make a plot, replace the bracketed sections in the code with a dataset, a geom_function, or a group of aesthetic mappings. We can make all kinds of different plots using this template. For example, Instead of plotting the relationship between body mass and flipper length, we could use two different variables in the penguin's dataset. Let's try bill length and bill depth. We can put bill length on the x-axis and bill depth on the y-axis. Let's run the code and check out this new scatter plot. As you learn to write code in R or any other programming language, you'll come across problems. It happens to everyone. I've been working in R for years, and I still write code that has errors. A lot of times, these will be minor errors with easy fixes. It helps if you pay attention to the details. For example, R's case sensitive. If you accidentally capitalize the first letter in a certain function, it might affect your code. Also, make sure every opening parenthesis in your function matches with a closing parenthesis. Notice how this code won't run correctly, but this code does. One common problem when working with ggplot2 is remembering to put the plus sign in the right place when adding a layer to your plot. Always put the plus sign at the end of a line of code. It's easy to forget, and put it at the beginning of the line. Or you might accidentally use a pipe instead of a plus sign. We all make mistakes. That's part of the learning process. The good news is we have plenty of tries to get it right. There's also plenty of resources to help you out. To learn more about any R function, just run the code $function_name. For example, if you want to learn more about the Geom_point function, type in $Geom_point. As a new learner, you might not understand all the concepts in the help page. At the bottom of the page, you can find specific examples of code that may show you how to solve your problem. If you still can't find what you're looking for, feel free to reach out to the R community online. As we mentioned earlier, there are tons of great online resources for R. Chances are, someone else has had the same problem. That's it for now. Up next, we'll learn more about aesthetics. In this video, you'll learn how to change the aesthetics of your visuals, which can help you present your data in a more compelling way. With aesthetics, you can highlight key points in your data and communicate more clearly and effectively with your stakeholders. Earlier, we learned that an aesthetic is a visual property of an object in your plot. For example, in a scatter plot, aesthetics include the size, shape, or color of your data points. You can display a point in different ways by changing its aesthetics or the way it looks. You can make a point small, triangular, or blue, or a combination of these. Let's go back to our penguins dataset and review the code for our plot that shows the relationship between body mass and flipper length. As a quick refresher, the mapping equals AES part of the code tells R what aesthetics to use for the plot. You use the AES function to define the mapping between your data and your plot. Mapping means matching up a specific variable in your dataset with a specific aesthetic. For example, you can map a variable to the x-axis of your plot, or you can map a variable to the y-axis of your plot. To map an aesthetic to a variable, set the name of the aesthetic equal to the name of the variable inside the parentheses of the AES function. Our code tells R to map flipper length to the x-axis and body mass to the y-axis. Let's log into RStudio Cloud and run the code. As a quick reminder, let's start by loading the ggplot2 package and the penguins dataset. R will automatically place the appropriate label on each axis of our scatter plot. After you map a variable to an aesthetic, R takes care of the rest. You can also map data to other aesthetics, like color, size, and shape. Right now, our plot's in black and white. It clearly shows the positive relationship between the two variables. As the values on the x-axis increase, the values on the y-axis increase. But it's also got some limitations. For example, we can't tell which data points refer to each of the 3 penguin species. To solve this problem, we can map a new variable to a new aesthetic. Let's add a third variable to our scatter plot by mapping it to a new aesthetic. We'll map the variable species to the aesthetic color by adding some code inside the parentheses of the AES function. We'll add a comma after the body mass variable and type color =, species. Our code tells R to assign a different color to each species of penguin. Let's check it out. The Gentoos are the largest of the 3 penguin species. The legend just to the right of the plot shows us that the blue points refer to the Gentoo penguins. Not only does R automatically apply different colors to each data point, it also gives a legend to show us the color coding. That's what I love about R. Give it just a little bit of code and it'll go the extra mile to help you out. We can also use shape to highlight the different penguin species. Let's map the variable species to the aesthetic shape. To do this, we can change the code from color = species to shape = species. Instead of colored points, R assigns different shapes to each species. Now, the legend shows us a circle for the Adelie species, a triangle for the chin straps, and a square for the Gentoos. You might notice that our plot's in black and white again because we removed the code for color. Let's put some color back into our plot. If we want, we can map more than one aesthetic to the same variable. Let's map both color and shape to species. We'll add the code color = species while keeping the code shape = species. Now, our plot shows a different color and a different shape for each species. We can keep going. Let's add size as well and map 3 aesthetics to species. If we add size = species, each colored shape will also be a different size. Using more than one aesthetic can also be a way to make your visuals more accessible, because it gives your viewers more than one way to make sense of your data. We can also map species to the alpha aesthetic, which controls the transparency of the points. Our first plot showed the relationship between body mass and flipper length in black and white. Then, we mapped the variable species to the aesthetic color to show the difference between each of the 3 penguin species. If we want to keep our graph in black and white, we can map the alpha aesthetic to species. This will make some points more transparent or see-through than others. This gives us another way to represent each penguin species. Let's try it. Alpha is a good option when you've got a dense plot with lots of data points. You can also set the aesthetic apart from a specific variable. Let's say we want to change the color of all the points to purple. Here, we don't want to map color to a specific variable, like species. We just want every point in our scatter plot to be purple. So we need to set our new piece of code outside of the AES function and use quotation marks for our color value. This is because all the code inside of the AES function tells R how to map aesthetics to variables. For example, mapping the aesthetic color to the variable species. If we want to change the appearance of our overall plot without regard to specific variables, we write code outside of the AES function. Let's write the code and run it. That's all for now. We just learned about the most common aesthetics for points: X, Y, color, shape, size, and alpha. We also discovered how aesthetics can change the look of our plot and highlight important data. We've covered a lot so far and learned a bunch of new concepts. It takes time to process new information and learn new skills. So feel free to watch any of these videos again if you need a refresher or want to practice in RStudio. Coming up, we'll learn more about Geomes. In this video, we'll learn how to use different Geome functions to create different types of plots, such as scatter plots and bar charts. There are lots of different Geomes available. You can choose a specific Geome based on how you want to represent your data and your goals for communicating it. This lets you tell the story of your data in different ways and communicate effectively to different audiences. Let's start with two visualizations. Both visuals contain the same X variable and the same Y variable. Both use the same data, but each plot uses a different visual object to represent the data. One uses points, the other uses a smooth line. In other words, they use different geomes. In ggplot2, a geome is the geometrical object used to represent your data. Geomes include points, bars, lines, and more. The geom_point function uses points to create scatter plots. The geom_bar function uses bars to create bar charts, and so on. To change the geome in our plot, we need to change the geom function in our code. For example, take the plot that shows the relationship between body mass and flipper length. The code uses geom_point to create a scatter plot. Let's log into RStudio Cloud and watch what happens when we change geomes. First, let's load the ggplot2 package and the penguins dataset. Now, we can put geom_smooth in place of geom_point. We still have the same data, but now the data's got a different visual appearance. Instead of points, there's a smooth line that fits the data. The geom_smooth function's useful for showing general trends in our data. The line clearly shows the positive relationship between body mass and flipper length. The larger the penguin, the longer the flipper. We can even use two geomes in the same plot. Let's say we want to show the relationship between the trend line and the data points more clearly. We can combine the code for geom_point and the code for geom_smooth by adding a plus symbol after geom_smooth. Let's write the code and run it. Let's say we want to plot a separate line for each species of penguin. We can add the line type aesthetic to our code and map it to the variable species. Geom_smooth will draw a different line with a different line type for each species of penguin. The legend shows how each line type matches with each species. The plot clearly shows the trend for each species. Finally, let's check out the geom_jitter function. The geom_jitter function creates a scatter plot and then adds a small amount of random noise to each point in the plot. Jittering helps us deal with overplotting, which happens when the data points in a plot overlap with each other. Jittering makes the points easier to find. I'll show you what I mean. Let's replace geom_point with geom_jitter. Now that we've seen what ggplot2 can do with scatter plots, let's explore bar charts. We'll use the diamonds dataset that you're already familiar with. This includes data like the quality, clarity, and cut for over 50,000 diamonds. This dataset comes with the ggplot2 package, so it's already loaded. To make a bar chart, we use the geom_bar function. Let's write some code that plots a bar chart of the variable cut in the diamonds dataset. Cut refers to a diamond's proportions, symmetry, and polish. Notice that we didn't supply a variable for the y-axis. When you use geom_bar, R automatically counts how many times each x value appears in the data, and then shows the counts on the y-axis. The default for geom_bar is to count rows, but that's only one of the many different applications for bar charts. For example, the x-axis of our plot shows 5 categories of cut quality: fair, good, very good, premium, and ideal. The y-axis shows the number of diamonds in each category. Over 20,000 diamonds have a value of ideal, which is the most common type of cut. Geom_bar uses several aesthetics that you're already familiar with, such as color, size, and alpha. Let's add the color aesthetic to our plot and map it to the variable cut. We write the code the same way as we did with scatter plots and add color equals cut after x equals cut. Don't forget to put a comma after x equals cut to add a new aesthetic. The color aesthetic adds color to the outline of each bar. R also supplies a legend to show the color coding. Let's say we want to highlight the difference between cuts even more clearly to make our plot easier to understand. We can use the fill aesthetic to add color to the inside of each bar. In our code, we put fill equals cut in place of color equals cut. R automatically chooses the colors and supplies a legend. That looks great. I really enjoy using the fill aesthetic. If we map fill to a new variable, geom_bar will display what's called a stacked bar chart. Let's map fill to clarity instead of cut. Our plot now shows 40 different combinations of cut and clarity. Each combination has its own colored rectangle. The rectangles that have the same cut value are stacked on top of each other in each bar. The plot organizes the complex data. Now we know the difference in volume between cuts, and we can figure out the difference in clarity within each cut. This is just the beginning of what you can do with Geomes. ggplot2 has over 30 geom functions that you can use to make plots, and extension packages give you even more. The ggplot2 cheat sheet is a great resource for learning more about geomes. As you move forward and do more advanced data analysis, you'll find plenty of new geomes to work with. Until then, the geomes we just reviewed will keep you busy and let you do a lot with your data. Coming up, we'll learn how to use the facet functions to display our data in different ways. In this video, we'll learn how to use the ggplot2 facet functions to display our data in new ways. Facet functions let you display smaller groups or subsets of your data. A facet's a side or section of an object, like the sides of a gemstone. Facets show different sides of your data by placing each subset on its own plot. Faceting can help you discover new patterns in your data and focus on relationships between different variables. For example, let's say you're looking at sales data for a clothing company. You might want to break down your data by category to show specific trends. Children's clothing versus adult clothing, or spring fashions versus fall fashions. Or if you are running an employee engagement survey, you might want to break down your data by tenure and compare senior employees to new employees. ggplot2 has two functions for faceting: facet_wrap and facet_grid. Let's explore them both. We'll start with facet_wrap. To facet your plot by a single variable, use facet_wrap. Let's say we wanted to focus on the data for each species of penguin. Take our plot that shows the relationship between body mass and flipper length in each penguin species. The facet_wrap function lets us create a separate plot for each species. To add a new layer to our plot, we'll add a plus symbol to our code. Then, inside the parentheses of the facet_wrap function, type a tilde symbol followed by the name of the variable. Let's log into RStudio Cloud and check it out. As a reminder, we'll start by loading the ggplot2 package and the penguins dataset. You can find the tilde symbol in the upper left corner of your keyboard, just below the escape key. There! The separate plots show the relationship between body mass and flipper length within each species of penguin. Pretty cool, right? Facets help us focus on important parts of our data that we might not notice in a single plot. If your visual is too busy, for example, if it's got too many variables or levels within variables, faceting can be a good option. Let's try faceting the diamonds dataset. Earlier, we made a bar chart that showed the number of diamonds for each category of cut: fair, good, very good, premium, and ideal. We can use facet_wrap on the cut variable to create a separate plot for each category of cut. Let's check it out. To facet your plot with two variables, use the facet_grid function. Facet_grid will split the plot into facets vertically by the values of the first variable and horizontally by the values of the second variable. For example, we can take our penguins plot and use facet_grid with the two variables sex and species. In the parentheses following the facet_grid function, we write sex, then the tilde symbol, then species. Let's run the code. There are 9 separate plots, each based on a combination of the 3 species of penguin and 3 categories of sex. Facet_grid lets you quickly reorganize and display complex data, and makes it easier to spot relationships between different groups. If we want, we can focus our plot on only one of the 2 variables. For example, we can tell R to remove sex from the vertical dimension of the plot and just show species. Let's check it out. You can easily spot differences in the relationship between flipper length and body mass between the 3 species. In the same way, we can focus our plot on sex instead of species. Facets let you reorganize your data to show specific relationships between variables and reveal important patterns and trends in subsets of your data. That's all for now. Next up, we'll learn how to customize our plots using labels and annotations. In everyday language, to annotate means to add notes to a document or diagram to explain or comment upon it. In ggplot2, adding annotations to your plot can help explain the plot's purpose or highlight important data. When you present your data visuals to stakeholders, you may not have much time to meet with them. Labels and annotations will point their attention to key things and help them quickly understand your plot. Let's start with the label function. It's super useful for adding informative labels to a plot, such as titles, subtitles, and captions. For example, we can add a title to our plot that shows the relationship between body mass and flipper length for the 3 penguin species. A title will clearly indicate the purpose of the plot. Let's go over the code. First, we add a plus sign to add a new layer to our plot. Next, in the parentheses following the label function, we write the word title, then an equal sign, then the specific text we want in our title. Let's log into our Studio Cloud and check it out. First, let's load the ggplot2 package and the penguins dataset. Remember, put the plus sign at the end of a line of code. It's easy to forget. R automatically displays the title at the top of the plot. We can also add a subtitle to our plot to highlight important information about our data. To do this, we enter the code for a subtitle in the same way as a title. Remember to add a comma after the title argument before you enter your subtitle. R automatically displays the subtitle just below the title. We can add a caption to our plot in the same way. Captions let us show the source of our data. The Palmer penguins data was collected from 2007 to 2009 by Dr. Kristen Gorman, a member of the Palmer Station Long-Term Ecological Research Program. Let's cite Dr. Gorman in our caption. R automatically displays the caption at the bottom right of our plot. Titles, subtitles, and captions are labels that we put outside of the grid of our plot to indicate important information. If we want to put text inside the grid to call out specific data points, we can use the annotate function. For example, let's say we want to highlight the data from the Gen 2 penguins. We can use the annotate function to add some text next to the data points that refer to the Gen 2s. This text will clearly communicate what the plot shows and reinforce an important part of our data. Okay, let's check out the code. In the parentheses of the annotate function, we've got information on the type of label, the specific location of the label, and the context of the label. In this case, we want to write a text label. We also want to place it near the Gen 2 data points. Let's put it at the following coordinates. X-axis equals 220 millimeters, and y-axis equals 3,500 grams. Finally, let's write our text. The Gen 2s are the largest. Let's run it. Check it out! R automatically places the text label on the correct coordinates in our plot. We can customize our annotation even more. Let's say we want to change the color of our text. Well, we can add color equals followed by the name of the color. Let's try purple. We can also change the font style and size of our text. Use font face and size to write the code. Let's bold our text and make it a little larger. We can even change the angle of our text. For example, We can tilt our text at a 25-degree angle to line it up with our data points. Let's try it. That looks great. By this point, our code is getting pretty long. If you want to use less code, you can store your plot as a variable in R. As a quick reminder, to create a variable in R, you type the variable name, then a less than sign, followed by a dash. Let's try it with the variable name p. Now, instead of writing all the code again, we can just call p and add an annotation to it, like this. You get the same result. Some people like to see every step of their code listed out in front of them. So there are advantages to doing it the longer way. It's really up to you. I just want you to know that you've got options. Hopefully this gives you an idea of some of the ways you can customize your plots. Labels and annotations can be really helpful when it comes to highlighting important parts of your data and communicating key points. That's all for now. Coming up, you'll learn some useful ways to save your plots in ggplot2. In this video, we'll learn how to save our plots. Saving your work so that you can access it later is so important. It lets you continue to work on it yourself or share it with others. Being able to reproduce and share your work is a key part of your future analyst role because it lets you collaborate with teammates. They can double-check your work and offer feedback to help you improve it. So let's save our plots. To do this, you'll use the Export option in the Plots tab of RStudio, or the ggsave function provided by the ggplot2 package. First, we'll save our plots using the Export option. Then we'll use the ggsave function. Let's log into RStudio Cloud. We'll load the ggplot2 package and the Penguins dataset. To start, let's write some code and create the plot that shows the relationship between body mass and flipper length in 3 penguin species. Let's use the Export option in the Plots tab to save our plot. We can save it as an image file or a PDF file. Let's try saving it as an image. There are 6 different options for image format, including PNG and JPEG. Let's try PNG. Next, we name our file and click Save. Now, if we click on the Files tab, we'll find our file in the list. Let's open it up. Looks great! That covers the Export option for saving a plot. Now, let's check out the ggsave function. ggsave's a useful function for saving a plot. It defaults to saving the last plot that you displayed and uses the size of the current graphics device. Let's try saving our plot as a PNG file using ggsave. ggsave will automatically save the plot that shows the relationship between body mass and flipper length because this is the last plot that we displayed. We have to give the file a name and say what kind of file we want to save it as. Let's write the code. Within the parentheses of the function, we start off with a quotation mark, followed by the name of the file. Let's name it 3 penguin species. We put a period after the file name, then the type of file we want, then a closing quotation mark. Let's run it. Now, if we click on the Files tab, we'll find our new file in the list. Let's open it up. Again, looks great. That covers the basics of saving plots. After all your hard work creating plots in ggplot2, you definitely want to remember to save them so you can access and share them later on. And that's the end of our work on data visualization. You're off to a great start visualizing data with ggplot2. Plus, the concepts we've covered are a great base for learning even more about data viz in R as you move forward.